first of all, thank you for inviting me to talk about something else than Pokemon. So I'm going to explain to you how to build your own Minecraft game. And I'm going to use Three.js, which is a library which allows you to do crazy and fun stuff. First up, before I start, I'm going to explain, he already told about me. So I'm Bert Timmermans. I work as an application designer for Digi. Digi is a Belgium agent. We do some similar stuff like Netflix does. But we have an office in Belgium, and starting next month we'll have an office in New York too. So I'm lucky to go there to help them start up the new agency there. So we do a lot of fun stuff. Also explained, I made a sort of Pokemon equivalent in JavaScript. I did this project and it was really fun. And in that talk I also explained about how I had to make something that looks like this, like a map editor, to rebuild all the maps of Pokemon to allow the game to use these map data and to generate the maps and make it playable. I also redone it. It looks pretty similar, but it's completely from scratch. But I spent a lot of hours on this. But for me, this was like, it was fun to do. But then again, if you want to build a map, it's pretty complex because you have to draw everything. So I was thinking about, why don't I make something that generates random maps? And that was sort of the starting point for me, for making my own Minecraft. So back to the presentation. So what do you need to make your own Minecraft? First of all, you have to find a way to generate data. Because if you play Minecraft, it generates a random world. And it's not just pushing a button and you get this magical data. Then we have to find a way to generate it in a sense that the world you generate is sort of logic, that you have hills, that you have seas, you have beaches. So the next thing you need is a way to visualize that data, because data is like ones, zeros, it's numbers, but it's not something visually. So that's, to visualize it, I use Three.js, but I will explain later. And then again, if you have something that's visual, it's pretty static because you don't have interaction. So you have to add some interaction so you can walk in that world, have sort of collision detection. If you walk against a block, that you don't just walk through it, but you stop, etc. First of all, generating the data. For this, I started with something that looks like this. I don't know if you have seen this type of maps. I think it's, in English, it's topographical map. It displays the elevation. So the blue thing is like the sea is very deep, while the darker you go and even to the gray, you get sort of three hills. This was pretty interesting because this was for me a starting point. I wanted to do something that generated something like this. So I looked at this part and I thought, this thing is something I can use. So you have this elevation chart which has the colors. So I took this, and for this I made an example. For example, I have like 0 to 5, which has the different heights. And for example, 0 is deep in the sea, 2 and 3 are grass, and 4 and 5 are hills. And I was thinking, why don't I generate something like this? You can easily generate with JavaScript some random numbers, and if you put them in sort of a grid, you get something like this. But this doesn't look like the thing I wanted to make. So I started thinking about how can I refine it, how can I make it smoother, because with some imagination you can see this as a sort of a sea. These are hilltops, and this is again some sea, but it's still it's really rough. It's like just some colors. So I thought about maybe how can I get some more detail, and I did this by taking a tile and splitting the tile each time into like 2 horizontal and 2 vertical. So and while I was doing this, I compared the current tile with the neighbors, so you get a sort of smooth out way. And if I repeated this multiple times, I get something like this, which looks pretty interesting, but it's not like what we're looking for. Because you can see you have a big sea here, but it's really noisy. Here you have some treetops, even the white is snow in this case, this example. So you have a beach, but it's like, it's cluttered. So I thought about, it's interesting data, but can I make it smoother to look like the map I wanted to go? So I found a way to do it, and that's like comparing the tiles with their neighbors. For example, if you take a tile which has 1, for example, and you can take the neighbors. For example, we have 4, 3, 2, 5. You want to make this sort of smoother, so you have less noise in your map. Then I did something like you compared. For example, I took the corners and this value, I counted, make the sum of it, and then divide it by 5. So I get sort of like a tree, which is the middle of all those numbers. And did the same like around them, because if I do it only diagonally, you get sort of diagonal lines in your map. So you have to make it also, do it also like this. And for example, I get a 2 because it takes a number. So, and if you do it with all the numbers, you get something that looks like this. It's pretty smooth, and now we have sort of grassland and sea, which is more logical. And if I apply this to the map I showed you earlier, we get something like this. And now we have some islands. It's really pretty smooth. You have like this depth, and you have all these layers coming together close, so it's more logical. So I thought about, yeah, now I have the data, which is the first part. Now let's look into a way to make it more visually interesting. The first thing I looked at, for example, a square. If you tilt it and, for example, looks like an hexagon. Why a hexagon? For example, some of you have played board games. You have special board games which use this shape because you can make random rolls with it. I used that shape and used the same data I had, but this time I generated something like this, which also looks pretty nice because it has more corners, which for the eye looks a little bit smoother. But then I thought about, yeah, I have this hexagon, why I don't make a cube out of it? So if I did this, I get something like this. This is still a 2D map. It's not 3D, it's just a visualization of the data I had before. But this already looks interesting because you get, this is like a hillside and this is going down, so it's pretty small. I have also this type of sea here, like I had some, while I was generating this, I drew every layer onto a canvas, and then for the water I had this special layer which is just blue with opacity, so it looks like water. But this was interesting. I mean, I had something that looks really nice. But then a colleague of mine was experimenting with something called Three.js. What does Three.js do? It's a library which you can find on Three.js.org, which shows you a lot of cool examples because it's crazy what you can do with it. Especially this flamingo, you have to check it out if you have the time. It's really cool. But you can download it, and they have like this documentation, and what they allow you to do is to have WebGL, which is a sort of way to generate 3D graphical stuff using your GPU, your graphic card, not your CPU. What's the difference? The GPU is made for doing graphical stuff, like your CPU does more the logic. And if you do it with this, you can get like this high quality graphics, shading, lighting. It's all available, and it's pretty simple to start with. So I made a small example to explain you with some code how to make something that looks like this. For example, we have a cube, which has a sort of light source coming from here. So you see this side will always be a little bit dark. So this is pretty easy to make. If you look at the code, first of all, I think all of you are sort of familiar with HTML. I don't want to make the wrong decision here, but this is, for example, basic HTML setup, and I only do is some basic CSS just to reset some stuff, and have Three.js and have a place to put my code. And I'm going to explain line by line what I need to make something like the cube that rotates. First of all, you have to have a scene. Three.scene allows you to create a scene, which is, what is a scene? It's like a 3D space, which you can put things in, you can put lights in, you can put objects in. The next step you have to do is a renderer, which renders your scene to something visually. Next up is a camera, because if you have a 3D space, you need a camera to have a sort of angle which point you're going to view the object or the space within. This code, yeah, the renderer is just using the width and height of my window. It appends it to the HTML, to the DOM. The camera is a sort of perspective camera. They have different types of camera. I only experimented with the perspective one. This is also my first Three.js project, so I'm not always sure what it is, but it sort of works always. Then I add the camera to the scene, which we first created. So we have to put the camera and put it in the scene. Next up, I'm going to make a cube. To make an object in Three.js, you need two things. First of all, we need a geometry, which is sort of the information about how your object is built up. Which faces does it have, which position does it have, which rotation does it have, and all the faces and all the stuff, it's in the geometry. The second thing you have to define is the material. The material is a thing that is a skin around the object. Which color does it have, which texture does it have, that's the material. In this case, I just made a box geometry from 1, 1, 1, so it's a cube. So, and just a color blue as a color. Then I put those together into a mesh, which is the 3D object. And then there's the geometry and the material. And then I add the cube to the scene. Next up, we have to add some lighting, because everything is dark, because there's no lighting preset. So first thing I do is an ambient lighting, which just lights up the scene equally. So it's not a light source that comes from one side that casts shadow, it's just equally lit up the scene a little bit to make it a little bit less dark. And then I add a light source, which is direction light, it's like a spotlight, and I put it on the object. And you can set the color and I set the position, like if this is 0, it sets it's 1, 1, 1 to the front, so it shines down to the center. And then you add the light to the scene. The last thing you have to do is define a render function, which uses request animation frame, which is a way to generate up to 60 frames per second, so you get really smooth frame rates and animations. And each time, if I loop it, I rotate the X and Y with 1%, so you get something that moves around. And then also you have to tell to render the scene, and you start to render, and each time the request animation frame does this loop, and let's create something that looks like this. So it's not a lot of code. It's all already divided into pieces, like you have light source, you have objects, you have your scene. They have a lot of examples and also a lot of documentation how to do this. So I figured out how to do this with Three.js, and now I was thinking, okay, I have this 2D map, how can I combine this? Basically, it's you could say I have this cube. Why do I put all these cubes onto the top of each other and create something that looks like this, for example, and I have a 3D world? This works, but there was a problem with it because it's run pretty smoothly on my computer, but if I run it on my phone, it doesn't work because it was too much for the phone. And basically, I discovered after reading some articles and examples that it's because I'm rendering too much stuff. I mean, the thing is, you only have to render what you see. So if you take away the material, you see that there are a lot of extra lines which you don't actually see. So I switched from cubes to generate planes. And what I mean, a plane is like one side of a cube or of an object, which is just a flat panel. And I build up my cube, only render the faces which are visible, and the other ones I don't render. So I remove all the extra lines which I don't need. So you only have the lines which you need. I put the material back on, and then you have something that's 3, 4, 5, 6 times faster to render because it's less for your phone, and you can generate bigger worlds and more stuff. Now I told you about lighting and shadows. So in this case, I didn't have anything set up yet. So for this case, everything is dark. First thing I added was an ambient lighting, which just lit up the scene, so there's an equally lit up, so there's nothing special about it. Then I have some direction lights, one from the top, one from the side, and from the other side, just light up unequally, so we get sort of depth into it. And then I added also some shadows, which was pretty complex. I'm not sure I'm going to cover this in this presentation, but what it comes down is that I have written a function which each time if I render the world, each face, it checks which corners are colliding with, and it generates the shadow of that face. But I can explain you later, but it's a little bit too complex to explain you how I did this. But yeah. So the next question, the type of shading is called Ambient Occlusion. it's like, what I did was sort of a simulation of what it could be, but there is no game which actually uses ambient occlusion. It's just a term of sort of shading. You can look it up on Wikipedia and stuff like that. It's a way to add this extra level of detail to your 2D object, and which is not doable with a specific light source. So how does it look like? Actually, it just looks like this. So this is really a render without touching of any Photoshop or stuff. So this is how it looks like. So next up is adding the interactions. In this case, we have an image, which is pretty nice, but I want to walk through the world and stuff like that. So I have to think about ways of interaction. Now, in this case, I had two ways of interaction. You have this keyboard with mouse, which is the basic one, which you're used to if you play first-person shooters. But then you also have touch, which is completely different because you don't have a mouse, you don't have a keyboard, you don't have buttons to check. So I had to find a way for each way to have the perfect controls to play the game and walk around in this world. I'm going to explain the keyboard and mouse, and I can show you it in the simulator, but I'm going to give you the URLs. It's online, so you can check it on your phone later after the keynote, how it actually plays a little bit. So I think it's now time that I actually show what I built. Let's see. So in this case, it generates a random world. This takes a little bit of time, but it also generates the 3D world and puts it in your memory. And that sometimes takes a little bit of time. In this case, it's a desktop computer, it's pretty fast, but on your phone, it's possible that it could take up to 30 seconds to see that it generates the world, but eventually it will show you this, but you have to wait. So it depends also which phone you have. If you have like an iPhone 6, it's 15 to 20 seconds. If you have an iPhone 5, you can wait up to 40, 45 seconds. Because this is just an early prototype I made, but it actually works. So in this case, I can, this is also something I implemented. Chrome and Firefox have this way of an API which allows you, if you click on a specific object, it locks your mouse, it hides your mouse, so you can have this like first-person movement without your mouse going out of the screen. It locks your mouse inside the object and creates the specific feel that you want to have with this game. In this case, I can also go full screen. Wait, let's see. Looks better. I don't need this. Okay, in this case, I can move around my mouse, and you see that's pretty fast. I can walk around. You can see that I automatically fall down. I have to jump to get onto the objects. I'm looking for some water, so you can see. But my friend was laughing with me when I was working on this, because sometimes I had to find water, and then I have to walk all through this wide world because it's completely random to find water. In this case, I succeeded to generate a world without water, so I have to. But I just let's see, to make sure. I think there's no water in this world. Just refresh and generate some world. Okay, yeah, so it's a little bit buggy because my camera is inside that block. But so there's water. Because I also added water in this world. There is, lucky me. In this case you have this water, which is transparent. If you see around, for example, if you look a little bit, in this case it's all sharp, but if I generate bigger world, you see that this is already getting a sort of misty. There's a sort of mist effect in the game to add that depth feeling. And I use that same effect if I go inside the water to create this limited view. For example, in this case, it's all foggy because it's the water. It has a sort of density, so you cannot see that far. But if I jump, I'm a little bit drowning now. But if I jump, you see that you can have this visibility again. So this is an effect I played with. Like this mist effect is something that's default with Three.js. So you can turn it on. You can collaborate. You can set it up like you want to. So. Okay, let's see. thing I still want to discuss is collision detection. Because you saw that I walked in that world, and when I hit a block, I couldn't go up that block. I had to press jump to get onto that block. If I went a block down and my character fell down or fell into the water, that's sort of, you have to add some physics and some collision detection. In this case, I worked on, for example, if I take our map again from my earlier examples, this is the data we have. But if we, for example, replace the colors with shades of white and black, and if we think about, if we see white as the lowest point of your map and black or dark as your highest point of the map, if you put a player on, we can read the colors of that spot on the map, and you can know which height this character has. So you can know what elevation your character has. So you can put your character somewhere on the map and it will put it on the right position. If you move around, it reads the pixel data of that next point and checks that point is on the same level. I can walk on the same level. But if you, for example, want to go and now press down, you cannot go in this direction because this is higher. So you will have to press jump, and then this jump will increase the height of the player, and then the player can jump on top of the higher part. This is sort of the basic explanation about how I did my collision detection. So to do this, I also generate a canvas element, which is not in the DOM structure, it's in the memory, which has this data. You will never see this map because it's in the memory, but it uses this map as a source to know where I can walk onto and where I cannot walk onto, which is a wall, which is not a wall. So to sum up, you need to generate the data in some way. My way was one of the ways, because I read also online that there were different ways to do this. There are some libraries to generate this data. You can do a lot of things with it. You have to find a way to visualize that data, and you have to have a way to add interactions to it. So that was it. I don't know if I have a lot of time left. Yes. How much?
10 minutes.
10 minutes. If there are some questions or... Yeah?
Yeah, I have a little question. I really think it's interesting to make a question that how you implement the canvas to use it as a memory for looking at the values of the height of the map.
Yeah, it's if you use JavaScript, you can create a canvas element using JavaScript. You can set, I want a new canvas, okay, it generates a new canvas, but you don't have to add it to the DOM.
Yeah,
and you can leave it in the memory, and you can call it, and you can use it to read the pixel data of that specific canvas. It's an API, which is default, which is built in your browser. So you can use the canvas element as an object, and then you can set, for example, I want to know the data of that point or that area, and it will give you an array of that data. And you can use that data to determine which is the elevation and which it's just a color, but you can put different types of data because you have the RGB and you have the alpha channel, which is all numbers. So with the height, I can use only the red, for example, and I can still use, for example, the other things as to put more data in it. So it's a data source, but it's also an image.
Yeah, so it will be more interesting to use that, in your opinion, than a multi-dimensional array.
Yeah, it's just a quicker way to call that specific data, because calling the pixel data is pretty fast, and you can also go a little more detailed because the pixel data is just one pixel, but you can make the pixel bigger. If you have round corners and stuff like that, it does more. So in this case, it's pretty square-based, but you can use the same collision detection, for example, for a first-person shooter with round corners and turns and ups and downs. In this case, it's just some squares, but you can also have gradients and stuff like that if you have a more complex world, when you have something that goes down slowly. I can also show you one thing more. The code is pretty flexible. In this case, I'm generating this Earth-like environment. And I have the settings like the size, the seeds, the loops, the color. The color is actually an array of all the colors, and that array I also use to build up the map of the height. So if I change this to something to, see, I can generate also on Mars like a world to just replace the data. And normally if I save it, let's hope it's correct. Normally it should be. Now we have a Mars-like world, because it's just changing the colors and the color of the sky and the height difference. Like there's only a limited height difference, and you can walk around. Now you see also the distance fog a little bit more. Yeah, not on the projector, but I can see it on the screen. Also, a fun thing you can do is I have my speed. If I want to be like the Flash, for example, I'm a big fan of that comic book character, I can increase the speed, and then I will run like crazy normally. Now run pretty fast. You can put it as fast as you want to. Also something I can change is, for example, the gravity. The gravity is just an indicator that calculates how long it takes to fall down, but if you decrease it, you have the feeling like you float a lot more. I think I have to decrease it by like this. It has been a while since I used this code. Normally, like this. Not again, I think. You see, if I jump, it's really, really slow. So we float a lot more. And also, yeah, there's water on Mars. That was something. We don't need NASA for it. I can figure out myself that there's water on Mars. So that was, in this case, you see here now the beam that you have sort of this distant fog, which creates sort of that feeling. So that was it. So that's what I had to show. Yeah.
What part of the program is consuming most CPU time? If you walk through the world.
It's 3.js, compiling my data into a 3D object, putting it into the memory, and once it's in the memory, it runs 60 frames per second. So that time, it's a lot. So
Yeah.
that's the most time. And yeah, if you use your GPU and use 60 frames per second, yeah, your computer gets hot. But also, if you play it on your phone gets also a little bit hot because of it does a lot of things at once in the browser. It runs actually faster than the real Minecraft. The real Minecraft does it at 25 frames per second. This does 60 frames. But yeah, this is not functionally. This is not comparable with the real Minecraft. But, so yeah.
So how much time do you think you've put into the project so far?
I think 45, 50 hours, something. But it's just in pieces. Like I worked on that small piece, and then I had some time. I did something else, like a week or two, and then I had the idea maybe I can do this, and I work on it, and then you try stuff, and then yeah, sometimes you spend like 8 hours of a weekend, or a full weekend sometimes, to get something right, because you know you have the knowledge of doing it, but you have to build it and test it if it works. So you have to also make sure that it's performant. That you can build something crazy, but if it runs like 2 frames per second, it's useless. So you want something that works really well.